In 1907, just a couple of years after he does his theory of special relativity, Einstein's a little bit worried. Special relativity only applies to bodies in a constant state of motion. He's trying to figure out, how does that deal with acceleration? There's another problem that we had all inherited by then from Newton, which is that there's something called gravitational mass, how much something weighs in the gravitational field, and there's something called inertial mass, which is how much force does it take to push it and get it moving. And inertial mass and gravitational mass are the same, but they're two different ways of explaining them. And Einstein really hated when there was two theories explaining one phenomenon. He wanted to unify it. And so then he has what's called his happiest thought. He imagines a person just falling, free falling in space. And he says, well, that person wouldn't feel gravity as he accelerated downward. And likewise, he imagined somebody in an enclosed elevator who's being accelerated upward in outer space where there's no gravitational field. He said, well, that person would still feel like there's gravity. If he took something out of his pocket and dropped it, it would fall to the floor at an accelerated rate. There'd be pressure up on his feet, just as if he were standing in a stationary elevator car on the surface of the Earth. So he realizes what he calls the principle of equivalence, that the effects of gravity and the effects of acceleration are equivalent. So there must just be one explanation for gravity and acceleration. And that's what the general theory of relativity is. It takes a notion of constant velocity motion, which is special relativity, and says, how are we going to apply it to accelerated motion? And he really comes up with this notion of a fabric of space and time, as if it's a fabric that sort of curves, like a trampoline fabric. You roll a bowling ball on it, and it curves because the bowling ball's there. Then if you put some billiard balls going afterwards, they kind of move towards the bowling ball. Why? Not because the bowling ball has a particular attraction, but because it's curved, the fabric on which they're rolling. Now imagine that in the 3 dimensions of curving all 3 dimensions of space. Pretty hard, right? But also imagine it in 4 dimensions, because what gravity does, it's a curving of the 3 dimensions of space plus time, the curving of space-time. Pretty difficult, but it all amounts to the most elegant theory in the history of science, the general theory of relativity.